Thanks everyone for tuning in to the October Angler Survey Committee webinar. We've got three great talks lined up. We got Susan Steffen talking about some of the human dimensions work that's been done with the Kansas Trout program. We have Matt Robertson is going to talk about some of the work he's done using the CrillCat database to evaluate some trends in catch and effort estimates, some regional trends in catch and effort estimates across the U.S. And also we have Chelsey Crandall, who's going to give another human dimensions oriented talk on some of the applied techniques for fisheries managers to use human dimensions techniques. So with that, I'll stop sharing and turn it over to Susan.
Great. I'm going to enable my screen here. All right. So, are you seeing the presenter slide?
I see the, yeah,
the note slide.
I see the
yes.
presenter slide, so you might want to do the other one.
Darn it. Okay, I'm going to stop and then share again on the opposite screen. Okay. Oh, no, I lost it. Sorry, y'all. Okay, how about now?
There we go.
Yay! It's going to look like I'm not looking at you because I'll be looking at the other screen now. Just when I think I have this stuff down. Well, good afternoon. My name is Susan Steffen. I work for Kansas Wildlife and Parks. I've been the Human Dimensions Specialist for going on 14 years for the agency. First person in this role pretty much came on board right after graduate school. So yeah, I've had several years of experience of conducting applied human dimensions research. I am in the Research and Survey Office in Emporia. I'd like to acknowledge my co-author as well, Jeff Connolly. Him and I kind of tag team this evaluation. And I don't know about you guys, but many times, like as a HD person working for a state agency, one of the major tasks that we get is usually to do program evaluation, which, you know, sounds kind of daunting. And I was really excited to give this presentation to you because in my career with the agency, it really seems like this is one of those evaluations where it went full circle. And what I mean by that is we went from identifying a problem, realizing that we needed some additional human dimensions information. We conducted a study, had some results, and talked about it with administrators as well as field staff, and we made decisions. We made decisions based on information. So that's really exciting for me to see that kind of happen full circle. And sometimes that doesn't always happen, right? We may conduct a study and you put out recommendations, but it just falls flat. So really good example of completing that cycle. And what I think is a core job duty of someone like me working in human dimensions. In Kansas, we do not have native trout. So this is a winter fishing opportunity only. And we've stocked trout since the early 90s. We offer this as primarily just a winter fishing opportunity. Those trout do not survive our hot summers. So it is strictly put and take. We sell between Yeah, 10,000, upwards of 10,000 trout permits each year, and that is required on top of a regular fishing license. So just trying to give you a little bit of history here about our trout program. No surprise, many things have gone up in price, and trout are no exception. We purchase most of our trout from public vendors or private interests, private vendors. Back in the early years 2011, this is as far back as the chart goes, we were experiencing prices as low as $1.50 per fish. Now in 2023, it's as expensive as $3.60 or $4.50 per fish. We calculated that based on the price per pound and then about how many fish we got. So that is even a low figure now. I think some of our prices have gone up even further, that our vendors charging us now as much as $5+ per pound, depending on where in the state it has to be delivered. Right, that's just due to gas. Gas has gone up, labor costs, the pellet food, all of that. And here's just a trend of what we're showing with the number of trout stocked versus cost. So we had this inflection point pretty much between 2015, 2016, where the cost is just starting to just go up astronomically. And what we're seeing here with our showing this chart of expenses versus revenue, this program was never self-sustaining. As early as 2010, we were funding the project from trout permit revenue at about 80%. We were able to make up 80% of those costs. However, you can see over time that gap is getting larger. So now we're not even paying for that program at a 50% level. We're just not selling as many trout permits as we used to. And it's certainly not enough to make up for the cost difference. So big problem there. We really realized as an agency, we had to do something different. We had to make some changes. This is something we can't delay it anymore. And one of the things that I like to say about human dimensions research is that really the answers to some of the questions that we have can vary based on the results we get. However, we really need to find palatable solutions. And so one of the ways I say this is, how do we tick off the least amount of people? And so, yeah, just for some of you who are not well versed in human dimensions and the kind of research we do, just trying to show you a little bit of behind the scenes, the kind of things that we take into consideration. So the goal was to come up with some of these solutions, because we definitely have to make some changes to the program due to cost. And one of the ways that we can make this more palatable for our anglers is to look at the various aspects, such as the locations we stock, seasons, size, just some of those aspects. Okay, well, it's no secret that response rates have been declining significantly. As early as 2009 in my career, I was getting 50% or higher response rates. And now we're down to, we're happy if we at least get 20. And that's for more traditional mail-in surveys or even mixed mode. So when I was tasked with finding out this information from our trout anglers, I approached our administrators and said, I really want to do some in-person interviews for this project. And the reason for that partially was as well to just put our employees in front of anglers to really show them the humanness of us, because if we are going to make some decisions that may not sit well with them, at least they know that we made an effort and we talked to them face to face. So that was important. I was very strategic in how I went about proposing that. And we even ended up having people from other divisions help us out, such as our park staff and our public lands guys. Some of them got out and did some interviews. So my backup plan, if we did not get enough interviews, was to do a mixed mode push to web survey or a postcard survey. But we did meet our goal, and the time frame of the surveys, the in-person interviews, was January through March of this year. Most of the surveys were conducted in February. We exceeded that goal of 400. Our people went out and really hit the pavement and got several interviews. So we did not need to do any of the additional survey work. So really, really great effort. And I think that's also worth mentioning as a part of a greater human dimensions type project and survey effort to really help expand and increase HD capacity and involve people that are sometimes making decisions, involve them in the process as well. So certainly had quite a few biologists out there get lots of interviews. So I only have 20 minutes. I'm going to try and go through the rest of the results fairly quickly here. This is a image here of Kansas, and these are the places where we did the interviews. And it was very important that we got a nice geographic spread of the different locations and the types of anglers that we interviewed. So we had quite a few interviews across the state. Looking at demographics now, we found that the majority of our trout anglers were mostly white males and had an average age of 51. And that was significantly higher than the average age of typical anglers that we come across. Like in our licensed angler survey, the average age I think is about 47, 44, somewhere around there. So that did surprise me a little bit that we did have some older constituents. Most people that we contacted were out fishing for trout. However, those that were not were primarily targeting crappie or just fishing for whatever, or maybe even catfish. And just to get some more demographic information, general participation characteristics, we wanted to know what their favorite species was to fish for in Kansas. And catfish came out as #1, and black bass, 22% indicated that was their favorite, and then shortly followed by crappie. Notice trout came in 4th place there at only 13%. We talked to trout anglers, and trout anglers who are actively out there trout fishing. Well, most trout anglers, even then it wasn't their favorite fish to fish for. So that's also kind of interesting. Our field staff really wanted to know this question, if people were being checked by game wardens, not just trout fishing, but just, hey, has a game warden checked you before? And this really surprised a lot of people. I was a little surprised it was that high, but they were thinking it was close to something like 0%. In reality, it's closer to 29%. Again, one of the pitfalls of human dimensions research, probably more so than your standard fisheries data, it's real easy for people to claim that BS card, like oh, that can't be right. Again, having the people involved in the project really helps kind of counter that BS card, because they were ones out there collecting the data. So no one to blame. Yeah, so trout fishing in Kansas. How important is trout fishing to you? The plurality, 34%, said it kind of meh in the middle. It's no more important than their other kinds of fishing. However, the next highest percentage at 32% said, hey, this is one of my most important. So again, we're kind of painting the picture here that it's an opportunity, but it's not something that's going to make or break them if they couldn't go trout fishing so far. People go trout fishing in Kansas most often in February, 31% said that. It is worthy to note that most of our interviews did occur in February, but we did have quite a bit of showing in the other months. So I do feel good that this is accurate. And you can see our trout season is quite long, 6 months. We wanted to know just some real general motivations here, and most people said that getting out of the house in the winter was their main motivator for fishing in the winter. And when presented with this dichotomous choice of what's more important, fishing in the winter versus outdoor recreation in the winter, and you can see on the y-axis those dichotomous choices. These are the percentages. So the purple is showing the majority answer in that case. By far, the highest percentage there is people really like to see trout stocked throughout the season. And the next highest percentage is their trout fishing their closest location, not necessarily their favorite. And then catching trout was more important for 2/3 of our respondents compared to harvesting trout. So that kind of surprised me. But yeah, those are important factors to consider when making the recommendations. And so we're starting to kind of fulfill our circle here. We're starting to come around, right? Where we, developed our problem. We know our problem. We developed a study, collected the data, and now analyzing the data and being able to say what that means and provide recommendations. I had the good luck of being mentored by Don Gablehouse early in my career, and he told me, he said, "Susan, don't be afraid to make recommendations." He said, "You are the expert, you can make recommendations. Doesn't mean anyone has to take them, right? But I make a point now of anytime I do a study, explicitly stating recommendations and being able to show not just what the data shows, but as well as how that can be applied. Because sometimes there's that mismatch between here's your data and then everybody's kind of left wanting. So that's where the recommendations come from, and it's backed up by that data that we collected. So I just propose that for future considerations that we, when it comes to stocking locations, we look at those population centers and kind of here's where you should prioritize based on the data and the frequency and timing of the stocking and the size of trout. If we can, let's opt for larger size trout. Again, these recommendations are based on the idea that we're trying to find palatable solutions. So we're not going to please everyone. But if we are going to make some changes, we might tweak the program. Here's some suggestions, some recommendations of where we can make those changes to be more palatable. When it came down to it, though, it really seems like our trout fishing opportunities, our winter fishing, really is not going to tick off too many people when we consider making some of these changes, because they did indicate that this is one of those fishing opportunities that's not of extreme importance to them. And 92% said they would still buy a fishing license if for some reason they could no longer trout fish. So we definitely are not going to lose a bunch of our anglers, which was a concern. But that I didn't expect that percentage to be so high. And oddly enough, again, just catching trout was more important than harvesting trout. And then here's kind of the cherry on top, right? So the title of this slide is Changes for Fiscal Year 24. That's right now. We collected data, came up with some recommendations, and then administrators and field staff and research staff, we had a conversation about this information. And then we made decisions on what we would do, what we would change based on this information. And so again, this is just kind of, fills my cup, makes me happy, because I'm collecting information and I'm putting forth a study, and it's actually resulting in change and decisions. So we decided to shorten our trout season, which also means that the number of times we stocked is going to be shorter. So we are shortening that season from originally November to April to now December through the end of March. So we're only going to stock 3 times. It's going to be December, January, and February, the first week. And if you remember, that's kind of counter to some of the survey results, because some people did indicate that they would prefer to see more consistent stockings throughout the season, whereas we're just kind of doing three stockings now. I think it's about half. Normally we would do about 6. We are just going to have to limit the number of trout that we stock, but hopefully enough that we still keep people engaged. And we are also implementing a little bit more targeted marketing program through Facebook and some of our social media to at least keep people engaged and aware of the changes to the trout season. We had toyed with the idea of decreasing the creel limit, going from a 5 to perhaps a 2 per day limit. And from previous creel surveys on trout anglers, we didn't do one this go around, but we did see not many people were harvesting a full creel. So we did keep that limit to 5. And then again, a more part of the planning process here, we also have a plan for fiscal year 25. It takes a long time for us to get our regulations through our commission and get those passed. So that's why we have kind of that 2-year look forward. So we are going to be more strategic with where we stock starting in fiscal year 25. We are going to seek an increase in the permit fee to bring in more money and officially change that trout season, as well as come up with new signage. So not just a one-off 1-year thing. This is looking, further into the future. And that's all I have. I just wanted to acknowledge all the people who helped collect the information in the agency, and my colleagues and the anglers, of course, who talked to us. So I don't know if there's time for questions. I tried to catch up a few minutes there.
Dave, you're on
Dave,
mute.
you're on mute.
Sorry about that, y'all. Yeah, it looks like Paul has his hand raised. I'll let Paul ask one question, and then we'll.
I don't know if anyone else can hear you, but you're kind of robotic.
Hello?
Sounds okay to me.
It's coming through okay, Dave.
All right, y'all can hear me now?
Yeah.
Yeah, let's Paul, go ahead and ask your question, and then we'll move on to the next talk.
Thanks, Dave. I appreciate it. Thank you, Susan. My question is, and it's a little naive, I think, but it has to do with how you evaluate these programs and the cost benefit ratios.
Mm-hmm.
And I think the math, and this is not your fault. I think this is like what is required of agencies and how when you're talking to governments and how they look at things. But I think there's more to it than just what you get in and out of it and all those externalities in terms of does anyone try to factor in the benefits in terms of health benefits, getting people outside, as far as the tackle sales and what that might mean to local businesses and those kinds of things. Is that ever included in the math? And I think it's unfortunate. I think the answer is rarely, and I think that's unfortunate.
Right. I would say definitely in this case, no. Should it be? I agree with you there. That is, when it comes to, being a state agency, like, man, that kind of stuff like barely meets our radar. I know that sounds bad, but
Yeah.
It's the reality. Yeah.
Yeah, just I guess it's the philosophy of governments shouldn't be run as businesses. They are providing a service
Yes.
at a loss, but across the state or across the entire, the benefits, health benefits of getting people outside, what does that mean for your state? It's never part of it. Okay, that's my question / rant. Thank you.
Yeah, thanks for that, Paul. I agree. We're government. We're not going to be efficient.
Right.
It's okay sometimes to be subsidized.
All right, well, we're gonna keep things moving. If y'all have any more questions, just throw them in the chat. And hopefully Susan will get to those questions. But with that, we'll move on to Matt and his talk.
Thanks, Dave. We'll try and share my screen here first. Can everybody hear me all right?
Yep.
Great. All right, can you see the presentation now?
Yeah, looks good.
All right, great. Thank you, Dave. Yeah, so hi, everybody. Good afternoon. Thanks for inviting me to this, Dave. My name is Matt Robertson. I'm a research scientist at the Fisheries and Marine Institute of Memorial University of Newfoundland in Canada. And today I'm going to give you a presentation overviewing a recent paper that we had published in Fisheries Management and Ecology, where we focused on trying to estimate lentic recreational fisheries catch and effort across the United States. And before I get into the presentation itself, I just want to make sure that I take the time to thank and acknowledge the many different management agencies throughout the US that have provided data to the Creel Cat program that I'm a part of, without whom none of this research would have been possible. I also think this slide may be a little bit out of date. So these sort of opening slides providing some context for the work that we did, I think will be a little bit of like well-done information for the people that are in this call. But our research focused on inland recreational fisheries. And as I think all of us know, these fisheries are really socioeconomically important. It's been estimated that about 13% of the US population participates in these fisheries and that they drive around $129 billion in economic activity. But despite this socioeconomic and ecological importance that we've recognized, at this point in time, we really don't have any good estimates of scale outside of those expenditures for these fisheries within the US. We understand that there's about 13% of people in the US that participate in them, but we don't know how much they're catching, how frequently they're fishing, how long they go fishing for when they do actively fish. Now, one way at which we get at understanding these questions at a water body scale is through creel surveys. I think as many people here know, these are in-person, on-site interviews that are focused on trying to estimate water body specific effort, catch, and harvest. However, because of the way that creel surveys are designed, oftentimes focusing on really specific management questions for local areas, water bodies specifically, we often see that the methods aren't standardized, especially across state boundaries, which makes comparing the estimates that we get from these surveys across those borders really challenging. However, if we were able to come up with a way of creating some sort of cross-state comparisons of catch and effort, harvest, other things that we get from these creel surveys, we might actually be able to inform larger scale research, potentially facilitate coordinated management practices across larger scales than just what we see at the state level. And it's with sort of that in mind that the research group that I'm part of working on started to develop what's known as the Creel Cat database. So what we did was we had a bunch of people contact state agencies, try and get them to submit as much creel information, creel data as they were comfortable with, especially data from 2010 onwards. And what people in our team have been working on is creating this database that sort of systematically organizes this data in a way that will be easily accessible. We now have it set up so it's a publicly available database. You can go to the link that I'm showing on the screen now and view what's actually here. Explore it, export whatever aspects of it that you're interested in. At the time of writing, we had data from 33 states, Washington, D.C., and Puerto Rico, that entailed about 15,000 creel surveys from across within each of those states. And we tried to record as much information as we could from the different creel surveys that were provided to us. These included information on fishing effort, catch, harvest, angler preference, demographics, and survey characteristics. So as I mentioned, you can go to this app, which you can see sort of the screenshot of the splash page here, and get all that sort of information for your state if your state provided that data to us. And so the goal of the paper that I'm talking about today was to use this new database and see if we'd be able to develop a model that would allow us to actually compare creel surveys across boundaries. Specifically, we were really interested in seeing if we could compare these different surveys to create a relationship between effort and catch that would be consistent among all these different surveys that we had data for. Within this overarching objective, we had sort of three sub-objectives. The first being to see if there was a conserved relationship between fishing effort and catch in lentic water bodies throughout the US, to see if we could estimate regional variability in effort or catch, and to see if there was any evidence that socio-ecological covariates helped explain variability that we were observing in fishing effort. Now, as I mentioned, we have about 15,000 surveys or so in the CreelCat database for the time being, but we really wanted to make sure that in this paper specifically, we focused in on the surveys that we thought would be most comparable to one another. I won't get into too many details about how exactly we subset those data down, but the data that we ended up using for this paper consisted of about 2,103 surveys from 999 water bodies from 18 different states in 6 of 7 regions throughout the US. And you can see the data that we used represented, at least the spatial extent of that data represented in the map that you can see on the slide now. The different colors represent the different regions that we examined, where darker colors specifically show the states that we had data for, and the black polygons represent the water bodies that we had creel survey data for specifically in each state. In general, we aggregated catch and effort across taxa. We were most interested in trying to see water body total catch and effort, not taxa-specific catch and effort. And also to ensure that estimates were comparable, we estimated daily catch and effort by dividing estimates of catch and effort by survey duration, just so we could have rate-based estimators that would be more comparable. Now, using that data, we then created a hierarchical generalized linear model, which I'm going to try and break down over the next few slides. The sort of core of this model focused on the relationship between catch and effort, which is what you can see on the screen now. And so the basics of this equation are that we were trying to say that catch was related to effort based on a catchability term and a linearity term. And the reason we included a linearity term here was because a number of different studies in the past have found that the relationship between catch and effort may be nonlinear. And we wanted to be able to use this model to estimate whether or not this relationship was linear or not. And so basically by including this linearity term, we'd be able to see what the shape of this relationship really looked like. So essentially, this will come up in the results. If B was equal to 1, we would basically identify that the relationship between catch and effort across all of our different surveys was linear. If B was greater than 1, that would be indicative that there was some sort of facilitation occurring, basically telling us that there's some sort of disproportionate increase in the amount of catch we're getting with effort. Basically, we would be getting more catch than expected as effort hours increased. Meanwhile, the opposite, if B was estimated to be less than 1, that would basically be telling us that there's some sort of saturation effect occurring, where we're expecting that catch will eventually reach some sort of asymptote as effort continues to increase. Now, as I mentioned, this model was developed to be hierarchical in nature. And basically, what I mean by that is we wanted to estimate 2 steps of this model, where the first step is trying to estimate how much effort we would expect to occur on a particular water body, and then use those estimates of effort in this equation that I just described on the last slide to then try and estimate catch. And so what you can see here is that we wanted to estimate effort as some combination of linear covariates, so basically just a normal linear regression, and then use those estimates of effort to feed back into that catch effort relationship that I described previously. Additionally, as I'd mentioned in the objective slide, we were really interested in seeing if there was any evidence that there was regional variability in either the base level of effort that was occurring or in the shape of the relationship between catch and effort. And because of that, through model comparison, we attempted to identify whether treating either this intercept term in our effort relationship or an effect in the linearity term in the catch-effort relationship could help describe regional variability that we were observing. Now, going back to the effort equation, as I mentioned, we basically just looked at using a linear combination of covariates, and we were interested in trying to identify which covariates were most informative about the variability we were observing in effort across space and time. And so to be able to do this, again, we used model comparison to identify which covariates were most important. We examined a number of covariates, which I've outlined here, including water body area, nearby land cover taken from the National Land Cover Database. And we examined this at two different scales. So we looked within 100 meters of each one of the water bodies that we had data for, or within 5,000 meters of the water bodies. We also examined the distance from each water body to the nearest primary road as a proxy of basically accessibility of the different water bodies. And we also looked at county level census data, specifically population size, median income, median age, and median household size, to try and give us some indication of whether socioeconomics were playing a role in how much people were fishing. What we ended up observing was that our best model formulation included a regional effect on the intercept for that effort equation, basically indicating that there does seem to be regional variability in the base level of fishing effort that's occurring in these inland recreational fisheries. And I'll talk specifically about how that variability looked in just a moment. And we also identified that there was a significant saturating relationship. So we saw that that nonlinearity term or that linearity term was less than 1, and significantly so based on the 95% confidence intervals. In addition, you can see in the plot shown on the slide now just how nice of a relationship there was between catch and effort on the log scale, where you can see the gray points here representing each one of our different creel surveys, the black line estimating the estimated relationship, and the blue polygon representing the 95% confidence interval around that estimate. So in terms of regional effects, as I mentioned, we observed that there were differences in the base level of effort by region. However, these differences that we observed weren't often significantly different from one another, where the Northeast was the only region that was significantly different from another region, and it was only significantly different from the Northern Great Plains. So here in this figure, what we're seeing are the estimates shown as the different points, and the lines represent the 95% confidence intervals around each one of those different effects. And interestingly, this finding has actually been shown before in a paper from the early 90s, where somebody had seen low participation in Northeast recreational inland fisheries. And their primary hypothesis for this was that due to the amount of coastline that exists within these states, they were actually expecting that people were more likely to split their time between marine and inland recreational fisheries, and as a result, spent less time fishing in inland waters than we saw in other regions. In addition, we found that there were 3 covariates that significantly affected our estimates of effort. The most important covariate was water body area, where we saw that there was an exponential effect of water body area. And you can see this in the figure here in the top 2 panels showing water body area on the log scale compared to log effort hours per day. The other interesting thing with this covariate was that we saw that there was actually a really different relationship between the effect of water body area between Great Lakes and non-Great Lakes water bodies. And so because of this, we actually estimated separate effects depending on whether water bodies were Great Lakes or not. We have a few hypotheses for why exactly this might be, but you can see that there was a very strong positive relationship between water body and effort hours per day on non-Great Lakes water bodies. And that relationship ended up being much shallower when we actually looked at the Great Lakes themselves. And this relationship has been observed in a number of different studies before and could be due to a wide variety of factors, including angler preference, where larger water bodies just have more space, so you don't have to compete as much for space with other anglers. It's expected that larger water bodies can have greater productivity, so you might have better chances of catching more fish, which may have anglers targeting these water bodies preferentially. There may also be different levels of access between small and large water bodies, which could help drive this relationship. In addition to this relationship between effort hours per day and water body area, we also estimated a significant effect of median age within a county, where we actually saw a negative relationship between median age of families within a county and the amount of effort they would spend in these recreational fisheries. This result is a little bit harder to interpret. People have found different effects depending on the particular fishery that they're examining. But one of the dominant hypotheses that I observed in the literature was that this could be something to do with physical ability, basically with older anglers potentially not being able to spend quite so much time angling as they had when they were younger. And then finally, the last covariate that we found to have a significant effect was distance to primary road, where we see a negative relationship with distance to primary roads, basically indicating water bodies that are closer to main roads will receive more fishing effort. And this seems like a pretty straightforward finding, where people will be more likely to fish in areas that they have easier access to. And now returning to that linearity term that I talked about at the beginning. So I mentioned how in our best model, we observed that there was actually a nonlinear relationship between catch and effort. And so this plot here is actually showing what that relationship would look like on the non-log scale. And I'm going to discuss why it's important. So if we look at this figure here, we can see a dashed red line, which is indicative of what the relationship between catch and effort would look like if we had simply assumed that the relationship was linear. Meanwhile, the black line and the blue polygon represents what we actually estimated it to be. And this is particularly important because, as I stated at the start of this presentation, one of the goals of this model is potentially to create better estimates of scale of efforts, catch, harvest that we're observing in these inland recreational fisheries. And if we were to start with a linear assumption between what catch and effort looks like, we would end up really overestimating what our catch numbers would be. And therefore, what this is telling us is that it's really important to, within the model, estimate what the shape of this relationship is. Now, we may be observing this nonlinear effect for a wide variety of factors, which probably deserve further research attention in the future. One of the primary factors that we may be observing here is that within our catch-effort relationship, we didn't include an effect of population abundance simply because that data doesn't exist. And this could be pulling the shape of this relationship in a few different ways. It's also possible that things like fish aggregation, effort sorting, even fish learning to avoid different fishing gears could be playing a role in this relationship that we're observing. But again, something that certainly deserves a bit more research attention. So with that, I have sort of three key takeaways that I'm hoping people that have watched this presentation will get. The first was that after examining inland recreational catch and effort throughout the United States, we saw that there was a nonlinear relationship between the two. We observed that inland recreational fishing effort varied in response to socio-ecological characteristics. Specifically, it was most influenced by water body area, median age, and distance to primary roads. And our hope is that this model will be able to be used in the future to try and come up with better estimates of scale for what the inland recreational fisheries in the US are doing in terms of harvest, catch, and potentially impact on the different ecosystems in which they occur, and generally just to explore regional and national trends in those fisheries. With that, if there's time, I'm happy to take any questions or comments. And if you're interested, you're more than welcome to read the paper that's been published in Fisheries Management and Ecology, as I mentioned before. Thank you.
Muted again, Dave.
Having trouble with that today. Yeah, does anybody have any questions here? I have a question. Since you found that effort and catch were nonlinear, I'm wondering why you wouldn't have gone with a nonlinear approach, something like a generalized additive model or something that could give you a smoother response to that nonlinear relationship.
The main reason we went with the approach we did was we kind of had a good estimate of what that relationship would look like. Those were the common relationships that people would expect, basically exponential or saturating. So we could specifically say we expect it to be exponential or saturating. Let's estimate what those would be rather than just letting the model guess what the shape would be, is essentially the idea there.
All right.
So we can just specify it ourselves. Yeah. Good question, though.
Nice. I see John has a hand raised.
Yeah, quick. I may have missed this. Nice presentation, man. I'm really interested in this stuff. Coming from Minnesota, we got a lot of data in there. And you said part of your hierarchical model was to predict effort, right? And I think there was a lot of observation and model fitting of the observed effort and catch, but you also, is that right that you guys were predicting effort? Or is that just part of that model fit? I'm not a stats geek, so I don't know if I'd missed something, but I'm really interested in that dynamic.
Yeah, thanks. Yeah, so the model is estimating effort. We're fitting it to the effort data, but it's trying to estimate it first, and then it's just fitting to it. We haven't at this point examined how good it is at predicting sort of in sample, out of sample type stuff. We haven't done any cross validation of the approach to see how well it would do in water bodies that we don't necessarily have data for, but that's kind of a next step that we're looking towards.
Yeah, we're very interested in that here. So once you figure it out, let me know.
Will do.
Thanks.
Thank you.
All right, great. Well, let's move on to Chelsey's talk.
All right, quick check. I think I'm going to be okay, but if I start getting towards the 3 o'clock cutoff, Dave, would you rather me shorten my talk or go a few minutes over?
No, just go a few minutes over. I think that's all right. And for those, if y'all have a tight deadline to leave, we are recording this talk and we'll distribute it to everyone. So, yeah.
Sounds good. All right, hopefully y'all can see that. Someone shout if you can't, assuming everyone can hear me because no one's staring at me blankly. So I'm Chelsey Crandall. Dave asked me to give a presentation that I recently gave at the American Fisheries Society meeting. So that is exactly what I have here for us today. So just to put that in a little context, this was the second year in a row that we've put together a symposium at the AFS meeting that's targeted at biologists and managers, maybe people who don't do human dimensions research themselves, to serve as an introduction to what the research is, what it looks like, give some examples of how it's applied in fisheries science and management. So this is set up as, again, more of an introduction to human dimensions. So I know for a few of the folks, fair amount of folks on the call, this might be a review for you. Some of you certainly know more about this than I myself do, so you're welcome to turn your brains off for a few minutes if you want, and then jump in on the end if there's anything you think would be helpful to contribute to this conversation too. Also, you might have noticed the little Easter egg picture. I put it in that slide because I can't help myself and I thought it'd be fun. All right, so I said I didn't change anything. I did add one slide just to introduce who the heck I am and why I'm here talking about this. So again, Chelsey Crandall, I'm with Florida Fish and Wildlife, and I lead our conservation social science research program. So we're a team of 5, sometimes 6, depending on how you count it, social scientists. And we work with folks across the agency to apply social science. So that's applying social science both to understanding the human dimensions of those activities like fishing, hunting, and wildlife viewing, but also some of our really complex management topics, things like imperiled and dangerous species management, non-native pets, invasive species. We got a lot of those here in Florida. Habitat management, some of our things that happen like red tide and hurricanes, understanding the impacts and outcomes of those, and a whole lot more. So we joke sometimes that we get to work on everything, everywhere, all at once, and it's a super fun place to work. We are a state of a little more than 22 million people, but we do have somewhere between 2 and 4 million recreational anglers. So we do end up doing a lot of work in fishing and fisheries. And I myself come from a fisheries background, so I enjoy working in fisheries projects. Okay, so again, this is an introduction to human dimensions research, just a primer to give an overview of what we're talking about when we say social science, when we say human dimensions. So to talk about human dimensions, we'll start with talking about conservation social science. And so you may be familiar with the social sciences, right? It's all of those fields that focus on people. When we talk about conservation social science, that's just social science applied in that specific context, right? So much like when we talk about conservation biology, right? We know that's actually a whole lot of different areas of specialty, disciplines, fields of study that fall under this big umbrella. It's the same when we talk about conservation social science. We're really talking about the conservation social science says. There's lots of disciplines, lots of areas of specialty that fall within this big old umbrella of conservation social science. So you might recognize some of these like sociology, anthropology, psychology, political science, and a whole bunch more. And I'll note in the corner here, you see human dimensions of conservation. And I'll bring that up because sometimes when people are talking about human dimensions research, they're talking about a more specific field of study that often focuses on things like attitudes, behaviors, preferences. But increasingly, when people talk about human dimensions, they're really looking at this interdisciplinary application of all of these fields to understand that human side of things, to where it's almost analogous with conservation social science. So when I talk about human dimensions, I really mean it in this broad sense. I use it as the same as conservation social science. But I bring this up just so that folks know sometimes when people say human dimensions research, they may be talking about different things. Sometimes they're talking about a more specific subset of questions. But again, I use it big and broad to be everything that's looking at the people side of things. And so given all of these fields that make up conservation social science, there are lots and lots of questions we can ask to help us better understand the human dimensions, right? So we can apply these fields to understand people as individuals, learn more about these individual attributes, people's underlying values, their beliefs, what they know, what they're doing out there in nature, their preferences, how they feel about things. But we can also use social science to understand these social processes, right? Look at how decision-making occurs, look at the process of management. And we can use social science to better understand these larger scale social phenomenon, things that are happening across communities, across scales. Look at things like norms, understanding governance structures, cultures and cultures and worldviews, and more. All right, so what I've done here is just give a few examples of how we've applied social science here in Florida. This was kind of a taster intro of social science. We already saw some examples today of how we can better understand human dimensions. These are some of the common ways we've applied it. But again, this is just an intro. We saw just now there's so many different things we can do to understand that human dimension across scales, across levels. But often we're trying to look and understand those individual attributes, right? Maybe we want to describe what's going on with our fishing public. For example, this was work that my predecessor did here at Florida Fish and Wildlife to learn more about our freshwater recreational anglers and learn things like, hey, what are the primary target species that folks are going for when they're freshwater fishing in Florida, right? Basic descriptors of what's going on with our freshwater fisheries public. Sometimes we want to better understand how people feel about management actions, management regulations, either that are already in place or maybe ones we're considering proposing. So for example, here we were looking at how people felt about the crappie bag limit. And this gives us insight into both how they feel about how things are now or how they might feel about certain changes if we were to, say, raise or lower the bag limit in Florida. And sometimes we want to explore what's going on with, again, some of our sticky, wicked problems, complex problems we have, like human-wildlife conflict. This comes up increasingly in fishing, right, when we talk about depredation or interaction with predators. You may have heard talk of shark depredation in Florida. That's been making it into national news in some spaces, I know. So in this case, we wanted to explore what's going on with these predator interactions across our different fishing sectors. What predators are they interacting with? Are there any hot spots or particular gears, things like that, that might be associated with these interactions? And we found, for example, that a lot of folks are changing their behavior when these interactions occur. Often this means moving or changing their location. So we can think about what impact that might have on their fishing experience, especially when we're talking about costs for charter and commercial fishers. And we also saw that there's a lot of different predators involved in these interactions. And so when we look at this from the biological side, right, we tend to come at it from the perspective of a species, and we look at depredation in the context of, say, sharks. But when we look at it from the people side, we can look across all of these species and see, for example, that some individuals are having multiple different interactions with many different predators. And so you can think of the compounding effects of that on their fishing experience, but also on their overall attitudes and perspectives when they're talking about these interactions. So we can also use social science, right, just like any other field of science, to look at relationships between factors and get an understanding of what might be affecting what what might be driving what. And for example, we can look at that in the context of conservation behavior. Often we have behaviors we want to promote, we want people to adopt that maybe are good for conservation, good for decreasing release mortality. We can use social science to better understand why people do or don't adopt those, or what factors or levers might increase adoption. In this case, we were testing some assumptions that we have about conservation behavior. For example, that, hey, people who go out in nature a lot, people who are out on the system, people who got influenced at a young age are going to be more likely to do conservation behaviors. And in this case, we were looking at behaviors that were being promoted to help improve water quality in an estuary in Florida. And what we found, and this is a super simplistic demonstration of this, and I can talk more about all of the nuances going on here later if anyone's interested, but none of these factors were significantly related to whether or not they were doing any of these behaviors. And then we also looked at how important they felt it was to improve the health of the lagoon. And you can see there that we saw, for example, folks who had never even been out on the lagoon thought it was pretty much just as important to improve its health as the folks that went out every day. So again, a lot of stuff going on here. This is just an overview snapshot, but it's an example of how we can use social science to understand all of the complexity that goes into behaviors and attitudes. And we can look at this in the context of management processes as well and how people feel about management. There's a lot of work looking at the different components of management decision-making and engagement. And a lot of the time we find that the process of management decision-making can be more important than the actual outcome. For example, if people perceive it to be fair, procedurally fair. So in this case, we looked at people's overall satisfaction with management and how it correlated with their perceptions of meaningful action. So whether or not they felt they could meaningfully engage with management, or for example, if it was just a box ticking exercise, it's something that came up in interviews we did a lot, that they engage us, but they're not really listening, it doesn't go anywhere. And we can see that that can correlate with their overall satisfaction with management. And we can use social science to evaluate different actions and interventions, right? Often we see this in terms of education campaigns. This was a workshop targeted at stocking programs in South Florida. And this is, again, a simple study, simple example, but it did a pre and post test to look at changes after people participated in this workshop. And we could see increases in knowledge, but not necessarily changes in beliefs and attitudes. We see that a lot. There's a lot that goes into, again, what informs beliefs and attitudes. Increasing knowledge does not always result in attitude change. And as we've seen, we can use social science to evaluate our own programs. This was work led by Kim Bonvecchio here at FWC to evaluate the freshwater fisheries long-term monitoring program and look at changes over time and see if they'd reached goals, for example, and they can use this information to inform directions that this program may take moving forward. So this was a survey of our own staff to look at, again, evaluating this monitoring program. And we can experiment with social science, right, which can be really fun. This is a really simple example, but we wanted to look at how effective an outreach video was in increasing knowledge and teaching people things they were hoping they'd learn about red tide. And so we did a simple quasi-experiment with 2 panel survey groups. One was just asked a series of questions about red tide. The other was first shown this video and then asked those same questions, right? Very simple experiment there. But we could see that those folks who'd seen the video felt more knowledgeable about red tide, and they'd also learned the things that we hoped they learned were more knowledgeable than those who hadn't watched the video. Excuse me. So again, just a few like intro overview examples. Again, this was set up to be like, hey, if you don't know anything about social science or what it might look like, these are some of the ways we can apply it when we're talking about understanding our fisheries, when we're talking about human interventions. But given all the things we can ask, we also know it's important to use the right tool, the right method for the right job. And there's lots of tools available to collect data about people. You may be familiar with some, if not all of these. A lot of us know about surveys. We also have lots of interesting qualitative methods like in-depth interviews and focus groups. We can go out and do observation and see what's happening. We can use secondary data sources such as census data that's out there. And those are just a few examples. Again, there's lots and lots of social science methods out there to help us understand what's going on with that human dimensions. This is, again, just a whole bunch of other examples someone else kindly summarized here. And so what we say is just like when we talk about biological science, right? There's lots of ways we can collect information about fish. Which method we use would depend on our research question, our system, our study species, probably resources and time available. And it's the same when we talk about human dimensions. Again, lots of tools available. We want to make sure we're using the right one. Plug for the social scientists that are here on the call. If you're in doubt, please, I always say, reach out to us at the beginning of a project because we can help make sure that we're using the right tools to get the data that we need. And so I'll briefly close here with this. And I know we're coming up on 3, but I often get this question. And again, folks here probably also have some great answers to this because there's a lot of folks on this call that work in this realm. But people will say, you know, hey, that human dimensions data is really cool, but what do I do with it? You know, I know where biological science fits into the work that we do. But what do we do with this people data? And so one example we give is how it can help us along the process of making management decisions. At the start, it helps us better understand our public in general, both, you know, how they're interacting with our resources, what they're fishing for, but also what's important to them about that experience. Learning about these things can help inform the actions we might consider taking. Once we have an action on the table, social science can help us gather feedback from the broad public, and it can help us understand things like perceived benefits or concerns that people might have. How do they think they might be impacted by this resource? Are there any potential negative impacts we haven't thought about? And then once we've implemented it, we can use social science to help us better understand impacts and outcomes, not just the economic outcomes and impacts, but also impacts to things like community health, culture, relationships, things like that. And you can apply this framework to a lot of things like communication, right? Social science can help us learn more about our audience and the channels they use to communicate. It can help us pilot test outreach efforts. It can help us evaluate how effective they are. And so that's just my big picture plug here that social science is another piece of this puzzle that helps us understand what's going on that human side of things. Again, I think folks here already know this, but because this was a talk designed for folks who might not know so much about social science, I like to close with this picture that says, you know, it goes alongside biological science to really help us see what's going on in the systems. And that is it. And I'm only 1 minute over. Thanks, y'all.
All right, thanks, Chelsey. Thanks to everyone that that presented here. Do you have any questions for Chelsey? All right. Well, yeah. Thanks again to everyone that presented. I think it's another successful webinar, and I appreciate everyone that tuned in. If this is your first time tuning in and you would like to get added to the distribution list for the Angler Survey Committee with information on the webinars and other activities that we conduct with this committee, you can follow that survey to just a few quick short questions to get added on to the distribution list. And yeah, with that, I thanks everyone for tuning in. And so our next webinar, it's going to be in January, and we've got Michelle Jones and Brian Riggers are going to give a talk on some of the work that they've done with the electronic license database to develop some creel estimates using some of the electronic data that that is not probabilistically based as typical creel surveys are. But yeah, we really appreciate everyone tuning in, and we'll touch base soon. Thanks a lot.